Rather than starting off tonight with a problem for you guys to do, I want to start off tonight with kind of a synopsis of the last 3 weeks and a little bit of a bridge into how that leads into what we're going to be doing. Now remember, we started out 3 weeks ago with simple interest. And simple interest is just that. It's the simplest way it can happen. Remember, interest is only calculated one at the end of the note. In other words, maturity. Or two, there's an action on the note, which is a really fancy way of saying a payment. We had two types of simple interest notes. We had the simple interest note. And you recall that was where the face value was equal to the principal. And to that you added interest to get the maturity value, which is what you paid back. The second type was a simple discount note. And in a simple discount note, the face value was the amount you paid back. From that, you would subtract a discount to get what's called your proceeds, which is how much you actually receive. Oh, my handwriting is horrible tonight. Yeah, that's better. I could barely read it, so I had to rewrite some of it. Because of this structure on that simple discount note, the stated rate is not the same as the effective rate. So there's an effective rate you have to find for a simple discount, or you don't have to, but you can be asked to find an effective rate for a simple discount note. The biggest thing about these simple interest and simple discount notes is you have a starting amount, whether that's your principal for a simple interest note or your proceeds for a simple discount note. It goes for a period of time, and at the end, you add in the interest, and then you get your maturity value, or the amount you pay back. Then last week, we talked about compound interest. Now, the biggest difference between compound interest and the simple interest that we're talking about up here, compound interest has a single starting amount, and that starting amount is called the PV, the present value, and that goes to an ending amount, which is called a future value. Looks the same so far, similar so far. The difference is you don't just wait till the end to add in interest. The interest is added in at regular intervals throughout the note. But you only deposit money into that account once at the beginning. The only reason the balance increases is the interest gets put in, but there's no additional deposits into that account. What we're going to be looking at tonight, we're going to start looking at annuity. What's that?
So this would have been on the last page. Are you trying to teach us like life lessons as well?
No, I'm just, because it's really easy to confuse these things all together. I want to make sure you know that when you look at a question, you know how to figure out which one it is. So for an annuity, we have that starting amount is going to be usually 0. And it's going to go to some future amount. And along the way, there's a payment that goes into it. And interest. And payments. And interest. And payments. At regular periods throughout the term of that investment. So we're going from simple interest, where you have a starting amount, you go all the way to the end, and at the end they figure in the interest and then what the ending amount is, to compound interest, the future and present value, where you had a starting amount, then every little while they add interest into it until you get to the end, to an annuity, where you usually start with a 0 balance. And then every little while, not only do you add in interest, but you make payments, principal payments into the investment every little while. And it can either look like what we just put here. That's what we call the investment, or the, I just blacked out, accumulation phase. You're starting out at $0, and you're paying in regularly, making payments into it to build it up to a future value. Or the other way is you start with a present value and you pay it down to 0. So you're withdrawing payments, but you're still adding in interest every period. So at regular periods of time throughout that life of that, you're taking money out, and they're adding interest in every period. This could be you retire and you have retirement investments and you're drawing money out every month to live off of. Or this exact same formula is what they would use to figure out loan payments, paying off a car loan or a mortgage loan or something like that where you have regular payments. This would be called the liquidation phase. If you're looking at an investment that you're drawing money out of, this would be the liquidation phase. You're pulling money out of it. Or if you're looking at a loan, it's called a sinking fund. By sinking fund, what it means is it starts out at its maximum balance. Its maximum balance is at the very beginning. And then over time, you're drawing the money out, and the balance is sinking until it hits 0. Similar to, but different mathematically than most of our checking accounts. Okay, good. So let's do some examples quick before we do materials. Obviously, these examples I'm going to do will not be annuities because we have not seen the math behind those yet. But let's see if we can remember the other type of stuff that we need to remember to do. So let's look at Pat wants to have $4,000 in 3 years to go on a trip. How much should Pat invest now at 6.2% compounded monthly? First of all, simple interest? Yes or no? How do you know no? Yeah, they actually say the word compounded. So it's compounded means no simple interest. Has to be compounded. So telling that it's compounded interest is pretty simple because it has to say compounded monthly, compounded quarterly, or compounded annually, or semi-annually. So yes, it is compounded. So then we know it's compounded, then the question is, are we looking for a future value or a present value? If it's a future value, we know how much we have now. We want to figure out how much we're going to have in the future. A present value, we know how much we're going to have in the future. We want to figure out how much we need to have right now. Which one is this?
Future value.
It's actually a present value. We know the $4,000 is how much we're going to have in the future. We want to have that much in the future. So we want to work backwards for how much do we have to start with now to get that known amount in the future. So present value is the future amount, the $4,000, times or divide? Divide by 1 plus, our rate is 0.062, divided by, what determines what we divide by? The monthly, compounded monthly. So that is 12 times a year. So divide by 12. To the power of 36. Good. That 36, remember, is 3 years times 12 months a year. Gives us the 36. Pretend that looks like a 3. There we go. So 4, 1, 2, 3 times parentheses 1 plus 0.062 divided by 12, power of 36. 48, 15, 38. Oops, I did times not divided. That's why that's not going to work. That's still not going to work. Let's just start over. 4,000 divided by 1 plus 0.062 divided by 12 to the power of 36. There we go, 33, 20, 70. 3,000. What's that?
Did you put in an extra 2?
That's possible. Oh, yeah, you're right. Maybe I still screwed it up. Let's try this one more time. We'll try this one more time, and if it doesn't work then, well, we'll try it again. $33, 22, 69. There we go.
Yes, that's what I got.
Okay.
I second that.
It only took me 3 tries. That's not so bad. Usually I restart my computer for this class because with the touch screen, after about 7 or 8 hours of operation, it doesn't the screen gets weird. And so I didn't restart it tonight, and I might regret it before the class is over. So anyway, that is compound interest looking for a present value. Let's say that Stacy borrows $7,000 on May 28th at 8.7% for 90 days. On July 6th, Stacy pays $3,000. How much is owed at the end of the loan? The end of the term. So, simple interest or compound interest? Yeah, it must be simple because it says 8% and there is no compounded or anything after it. So it can't be compound. If it was compounded, I'd have to say compounded monthly or whatever. Also, on the other hand, 90 days, we usually don't do compound interest for 90 days. Compound interest is usually, well, right at that limit would be 90 days. Usually it's at least 6 months. But we need to look up some days in our book.
148 for May 28th.
148 for May 28th. How about July 6th?
187.
187. Thank you. So we started out on the beginning, day 0, with that $7,000 loan. On July 6th, we have the payment. Stacy pays $3,000. We need to figure out what day that is. So 187 minus 148 is day 39. So day 39, we find the interest on the $7,000 at 8.7%, so 0.087. 39 over. It does not specify, so we use 360. It would have to say exact interest to use 365. So we get 7,000 times 0.087 times 39 divided by 360. Giving us 65.98. That's the interest. So before we make the payment, we have to add that to our principal to get the balance before the payment is $7,065.98. Then we can subtract the $3,000 payment to get that the balance after the payment is $4,065.98. And then, of course, nothing else happens until the end of the loan, maturity. Well, 39 days have gone past. We're going to take 120 minus 39 means 81 more days. 39 days had passed when we figured out this last payment. That means there's been 81 more days between that payment and the end of the loan, or maturity. So
Where'd you get the
Oh,
120?
yeah, good question. How about I actually do the problem that's in front of us? It was 90 days. Thank you. So there should be 51 days left. I would love to tell you if I make one more stupid mistake, we're going to call our night and go home, but yeah, I can't. I could tell you that, but it wouldn't be true. So our interest is going to be off the $4,065.98 times the 0.087451 out of 360. Giving us $50.11. That is again interest. So we must add that to our principal. So $4,116.09 is the balance due at maturity. That's how much you do at the end of the loan. End of the note. So there's a simple interest problem. Let's see, Kim has $10,000 to invest at 5.9% compounded semi-annually how much will Kim have after 8 years? Well, I'm not going to ask the silly question. What type of interest is this? Compound interest. Because it says compounded. Future value or present value? Remember, future value, we know how much we're starting with, and we want to know what we're ending with. Present value, we know what we want to end with. We need to figure out how much to start with. This is a future value. Very good. We know what we're starting with. We want to figure out what we're going to end with. That's the future values, that ending amount. So what's our formula going to look like? $10,000 times 1 plus 0.059 divided by 2. Where's the 2 come from? Semi-annually. You bet. Power of 16. You got it. 16. 8 years times 2 times a year gives us the 16. $15,922.88. So that's your future value. Let's say Chris borrows $4,500 at 9.2% on a 120-day simple discount note. Find the effective rate. I did find the effective rate because that requires us to find pretty much everything else. First of all, simple or compounded? This is simple interest. It's just a discount note, so we're kind of working backwards. We still find the discount, which is kind of the equivalent of the interest, right? How do we find that? $4,500 times 0.092 times 120 over 360. And it doesn't specify, so we assume it's ordinary interest and not exact. So we get $138. That is the amount of the discount. What do we do with that discount?
Subtract it from the 4,500.
Perfect. We subtract it from the $4,500, which is going to give us $4,362. And that's what's called the proceeds. So the effective rate is I equals PRT. We know I is that discount of $138. The principal, however, is no longer $4,500. We're going to use
4362.
the 4362. We are looking for the rate. The time is still the 120 over 360. So the first thing we have to do is combine those two numbers. So 4362 times 120 over 360. Oops, I put in the wrong number. Let's try that again. 4362 times 120 over 360 is 1454 times R. Now again, many times you're going to get a really ugly decimal that keeps going. Try to keep it in the calculator. If you can't keep it in the calculator, write down at least 5 or 6 decimal places so when you punch it back in, you don't get nailed with a huge round off error. What's our next step? Divide.
Divide 138.
You got it. Divide 138 by... I keep cutting you off there, I'm sorry.
That's okay.
138 divided by 1454. 0.09, remember we said to go at least 5 decimal places here. 0.09491 equals R. I did not specify, so let's assume we're going to the 100th of a percent. So first we convert to a percent by moving that decimal point to spot. 9.491%. Then, of course, that's going to round to 9.49. Find the effective rate for 9.2% compounded monthly for 37 years. Now, I did a couple of things here on purpose. One is, where's the dollar amount? Effective rate. There it is. Effective rate, dollar amount does not matter. We can put in whatever dollar amount we want to. Just make sure we use a big, I mean, if I put in like $2, the round off error is going to massacre us. So we make sure we use a large enough value. I suggest usually $10,000. So my interest, I'm going to figure out the future value. This is compound interest, right? So my future value is on $10,000 times 1 plus 0.092, that's my rate, divided by 12, because it's monthly. Now here's the one that you're going to get tripped up on. To the power of
444? No.
why did I just put 12 up there?
It doesn't matter.
Oh, yeah, it's like for 1 year. Greater than a year.
Greater than 1 year, use 1 year. If it's less than a year, you use the actual time. But if it's greater than a year, you go for 1 year. So what we're doing here is step 1, which is finding the future value. That ain't gonna work with that. Yeah, definitely didn't work. Let's try that again. $10,959.80.
Yes.
That's the future value. What do we want off of that?
Effective rate.
Well, we want to get the interest,
Oh,
which is going to be the 10,959.80 minus the 10,000. So interest of 959.80. Now we can do the effective rate. Remember, step 3 is I equals PRT. What goes in for I? 959.80. What goes in for P? 10,000. That's just the principal. We are looking for R, and our time is 1.
1.
So this one is convenient that way. So 10,000 times 1 is 10,000. So I'm just going to divide by 10,000. Gives me 0.09598, which is R. Move that decimal point. 9.598%. Now we have to round it to 100th of a percent. That's 9.60 is what that comes out to be. Any questions?
Hey, Todd,
Yes.
did you use 1 because it's a year?
Yep, because we're going for 1 year. Because it was more than a year, we used 1 year.
Okay.
Okay. So Sam pays $200 each year into an investment that earns 9% annual interest. How much will Sam have at the end of 8 years. What are we looking at here? This is not any of the things we've talked about so far. This has to hit our new stuff. This is what we call an annuity. How do we know the difference between this and the stuff we've been talking about?
Because we're adding them each year and not just like one
Yeah.
time.
We're making payments in on a regular basis. There's principal going in or out on a regular basis. Now we had that simple interest one where we made partial payments, but they weren't required to be made on a regular basis. They made the payment on day 41 because they wanted to, but they didn't have to or whatever. The annuity, that payment has to be made on a regular basis. As we mentioned, this is what we call the accumulation phase. Of an annuity. And what that means is there's money being paid in, and the balance is growing. It's accumulating. The amount that is paid in is the same amount every period. And there are regular periods. In an annuity, it is compound interest. The compound period is assumed to be the same as the payment period. I'm going to highlight that because it's very important. For the problems we do, I should say, the compound period will be the same as the payment period. So this one, the payments are made annually, $200 each year. Payments are made once a year. The interest only compounds once a year. It is possible to have annuities where the interest compounds more often than the payments are made. That is a real pain to deal with. Just going to say. If we get time before our last test, we'll look at some examples like that where the compound period might be different from the payment period, but it's no fun. That may be part of the extra credit that you guys get to do in the last week or so. So that is kind of fun. Extra credit's always fun, right? Just remember, it doesn't hurt me. Now, the other side of this is going to be, so what this is doing, this accumulation phase, you are starting out, as we had mentioned earlier, starting out at a zero balance. And I should label this is an ordinary annuity. We
I have a
just,
question.
yeah. Go for it.
Well, I've seen like in old people magazine, where they'll say, hey, for this charitable donation, like making it to a school, then they will pay you annuities. Now that's something different because it seems like it's like a huge amount that you pay in, and then do they somehow are making money off of your money, or?
Yeah, they're taking fees right off the top. You make that payment in, and they take fees right off the top, and then they pay it back out. In practice, there are a lot of annuity products out there. The traditional annuity products that you would buy from an insurance company, many of them have huge fees. And if you talk most, and I'm not an expert on them by any means, so I'm not going to get too deep into it, but most investment plan counselors would tell you that they're a good deal for the investment company and not so much for the investor. Because if you need that regular income and you don't have the discipline to do it yourself, it's okay, but you do pay a lot for that service. So anyway, the ordinary annuity, you have a balance. At the end of each period, you pay in. That's when you add your payment. At the end of the next period, I should try to make these periods the same length. End of the next period, you make another payment. I'm just going to plus pay, and then you add in the interest. There was no interest the first period because there was no balance coming into it. Again, another period, you add the payment, add the interest. Till you get up to the end, you build up to that future value. The future value is the amount you have at the end. So when you're talking about annuities, you can be talking about future value as well. So find the future value doesn't always mean you're looking at just compound interest. It could be an annuity. So you have to see if there's those regular payments being made in. Similar to an ordinary annuity is something called an annuity due. An annuity due also starts out with a zero balance. It also has these periods that build up to the future value. The difference is, I shouldn't say the problem, because it's not really a problem, but the difference is, in an annuity due, the payments are made at the beginning of each period. So like in the ordinary annuity up here, you start the ordinary annuity and you're going to make monthly payments. Well, your first payment doesn't get made until the end of that first month. Then the next payment gets made at the end of the second month and the end of the third month. In an annuity due, you start the annuity, your first payment gets made right away. So technically that zeroed balance only exists the moment you start the annuity. I mean, your first payment is due right away. So you go from a zero balance to at least the balance of that first payment right away. The first payment happens at the beginning of the period. What this means is at the end of an ordinary annuity, you're making your last payment at the very end, plus interest. For an annuity due, your last payment comes at the beginning of that last period. And technically, your balance right here at the beginning of that last period of an annuity due is the same as what your balance would be at the end of that last period, because everything's been made one period sooner. So what happens with an annuity due is you get plus interest for one more period. So the same interest rate, same number of periods, same payment, an annuity due will have a slightly larger future value because you're making the payments at the beginning of the period, so you get one more period's worth of interest at the very end. Then there is something called, so this is all the accumulation phase here. There's something called the liquidation phase we mentioned. In the liquidation phase, that's when you are drawing out or paying down. Either way, the balance is declining. The balance is getting less. So either you have an investment that you have that lump sum of money and you're drawing out that money on a regular basis to use it, or you have a loan like a car loan or a home mortgage and you're making those payments in on a regular basis to pay it down. Now, both of those examples, the car loan and the home mortgage, are kind of weird examples because we mentioned a few weeks ago, those are both actually simple interest. But the amount of your payment, when they give you what your monthly required payment is, that payment amount is figured out as an annuity because they're making the assumption that you're going to make your payments exactly on the 1 month intervals. But in real life, of course, you don't. So the amount of your payment is figured out on that assumption as an annuity, as a sinking fund, the liquidation phase of annuity. But by making that payment slightly earlier or slightly later each month, the actual ending balance can change. So you can actually end up paying it off a little bit early. Or it is possible, and I have seen it happen, you get to the end of the loan and there's still a small balance that's due. I mean, usually not more than a couple $100s, but you would still have to pay it off. That's if you start making payments, a couple of days late in that grace period regularly. It can be a few dollars left over at the end. It can't quite zero out. So anyway, let's get back to Miss Sam here. So we are going to assume Sam is an ordinary annuity. It did not state annuity due, so you will always assume ordinary annuity. And of course, that is unless stated. Just like with simple interest, you always assume ordinary interest unless it is stated as exact. This is ordinary annuity unless stated as annuity due. The formula. Okay. There is a reason why I am starting at the very left-hand side of the page. Just a note for while you're writing this down in your notes. Give yourself some room. So this is, we know the monthly payment. Actually, I shouldn't say monthly. We know the regular payment. We want to find the future value. That future value is going to be equal to the amount of the regular payment. Now I'm going to give you a note while you're catching up on your notes here. The way I'm going to write this out is going to look very different than what you see in the textbook. Because what you see in the textbook, they write out the formula in math type, math print. That's not how you enter it in your calculator. So the way I'm writing out this formula right now is the way you would enter it in your calculator in a line. So it's the amount of the payment times, there will be 1, 2, 3 open parentheses. This first part's going to look a lot like our compound interest. 1 plus our rate divided by n, where n is our number of periods per year, to the power of n times t, where n is your number of periods per year, t is your number of years. Subtracting off 1, that's actually to subtract off the initial principal. Then we're going to close the parenthesis again. Divided by opening another parenthesis, r divided by n. Close and close. So for Chris's situation here, the payment is $200 times 1, 2, 3 open parentheses. 1 plus 9% is 0.09 divided by how many times a year? 1. Once a year. To the power of 1 times 8, right? Once a year times 8 years. So 8 minus 1, close parentheses, divided by, open parentheses, 0.09 divided by 1. Close parentheses and close parentheses again. Now when you enter this, I've mentioned it before, I enter that power of 8. Many of you might have to put an arrow, a right arrow or a down arrow to get out of the exponent before you type in the -1. You get 2205.69. Now you think about that. This was Chris or Sam. Sam only paid in 200 times 8 or $1,600, and at the end has $2,205.69. Okay, I went a couple minutes past our break, so let's go ahead and take our break right now. We will start up again at 6:32.